Okay, again, this warm-up is going back a couple modules, I realize, but again, the skills from this are going to come forward into this inequality unit that we've been working on. So I just want to remind us of how we graph a line before we get into graphing a linear inequality that has two variables. So when I'm graphing a line, what are the two pieces of information that I need? Slope and y-intercept. So again, what I'm looking for, and I'm going to put this out in the margin here, I'm looking for it to be in y equals mx plus b, that slope-intercept form, where whatever is in front of the x, that m, that is representing my slope, and whatever that plus or minus number at the end, that is my y-intercept. So just to remind ourselves that that is what we are looking for. Now, you are going to have to sketch your own graph on this. Obviously, I can't provide you with a graph here, so you are going to have to sketch the coordinate plane yourself. So I'm going to pause and give you a moment to get that completed. All right, so again, these skills are a couple modules ago, but this is an important skill, honestly, that carries forward knowing how to graph. This is an important skill. So the first equation they give us is y equals negative 1/2 x plus 2. So again, there's two pieces of information we said we needed, the slope and the y-intercept. So what would be the slope of this equation? What number is in front of that x? Negative 1/2. And what would be my y-intercept? 2. So again, now you have to sketch your own coordinate plane. So I'm going to draw my x and y axes here. Now, because we are sketching our own axes, there is room for human error that we don't put everything exactly spaced. So I start at my y-intercept of positive 2. My slope says to go down 1, 2 to the right, down 1, 2 to the right. And then I use my straight edge to draw my line. So that's what the graph of y equals negative 1/2 x plus 2 should look like. Now in problem number 2, 2x plus y equals 4, they're giving me the equation in standard form. We said we need it in slope-intercept form, which means I need to get it where the y is by itself. So I'm going to subtract 2x from both sides. So we have y equals negative 2x plus 4. Now it's in slope-intercept form. So what is my slope for this problem? Negative 2. And what is my y-intercept? So again, now I do have to draw a sketch of a coordinate plane here. And again, once I have my coordinate plane drawn, I start with my y-intercept of 4. Negative 2 tells me to go down 2, 1 to the right. And again, I can use my straight edge to connect my points. So again, I know that these skills are a couple modules ago, but again, these skills of being able to graph a line are going to come up. The only difference today, we're going to be working with inequalities, so there are a few more steps that we're going to have to do besides this, but we need to remember that we need our slope and our y-intercept form. So we are moving on to graphing inequalities in two variables starting on page 21. All right, so graphing inequalities in two variables, very similar to what we were doing in the warm-up today. Obviously, there's going to be a few more steps. The graph of a linear inequality represents the set of all points that are solutions of the inequality. The edge of the graph is a boundary. Depending on the inequality, the boundary will or will not be included in the solution set. The boundary divides the coordinate plane into regions called half planes. When the boundary is included, the solution of the linear inequality is a closed half plane, and this is where we're going to use a solid line. When the boundary is not included, it is an open half plane, and we are going to use a dashed line. Now, the solid line and dashed line relate to the open circle, closed circle idea when we were just graphing on a number line. The solid line would be the same thing as a closed circle. The dashed line would be the same thing as an open circle. We use a solid boundary when the inequality contains less than or equal to or greater than or equal to, and we use a dashed boundary when the inequality contains less than or greater than. Again, a solid line is like an closed circle. A dashed line is like an open circle. So those same ideas still apply here as we're moving to the coordinate plane. So we're still doing the same things as far as needing to know our slope, our y-intercept, but then we have to determine, is this going to be a dashed line, a solid line, and to determine which side we're going to shade, we're going to have to pick some points. So there are obviously more steps here than just graphing a line. All right, so sketch the graph of the linear inequality. Now, this one just has one variable. This one says x is less than 1. X is less than 1. Anytime there's just an x, this tells us that we are going to have a vertical line. We do not have a y variable here, so this is going to be a vertical line at 1. But we do want to look at the inequality symbol. Would that be a solid line or a dashed line if we just have the less than symbol? This is going to be a dashed line. So because x is less than 1, we would go to 1 on our x-axis. And again, we're going to use a straight edge. And we're going to draw a dashed vertical line there at 1. And we want to make sure when we're doing a dashed line that we are showing that there are space between the dashes to make it very clear. Now, here's where the other difference, obviously that's one difference because we had to determine whether it's a dashed or a solid line. The other difference is we have to determine which side of this line we're going to shade. And how we do that is we pick a point on each side of the line to test. then shade the true side. So pick a point on each side of the line to test. Then shade the true side. So just like when we were working with the problems on the number line, we had to shade. Same thing applies when we get here to the coordinate plane. So I do like to use 0, 0 whenever possible. The reason I like to pick that as one of my points, doing math with 0 is very quick. So in this case, 0, 0 is going to be my test point for the left. And then I can pick a point on the right side. I'm just going to go with 3, 0 on the right. So I've picked 0, 0 and 3, 0. If I've done everything correctly, one of those should give me a true statement. One of those should give me a false statement. Now here, I just need my x coordinates because I just have an x is less than 1. So 0 is less than 1 when I substitute in. Is that a true statement? Is 0 less than 1? That is true. So if I substitute in the other one, I'm expecting to give me a false statement. Is 3 less than 1? No, that is false. So again, we said this side was true. We need to shade the side that has the 0, 0. And when I mean shade, it does not have to be completely covered in. We're just going to squiggle, but we do have to shade any part of the graph that is showing. But again, we don't have to solidly color it in. We don't have to waste time of making it solid, but we do need to make it very clear which side of that line we are shading. We are saying everything to the left of that line would be a solution to this inequality. Right, if we go to the next problem at the top of the next page, so we have y is less than negative 3/4 x minus 4. So this time we do have an x and a y. It is already in the y equals mx plus b format. We have the y by itself, and then we can see our slope and our y-intercept. But again, the first thing we want to do is look at this inequality symbol. Is this going to give me a dashed line or a solid line? Dashed. It's just less than, so dashed. And then what is my slope going to be here? Negative 3/4, and my y-intercept? Negative 4. So again, I'm going to start off graphing this line as if it was an equality. The difference, I know that instead of a solid line here, I'm going to put a dashed line. So I'm going to start at negative 4 here on my y-axis. Now my slope tells me to go down 3 and 4 to the right. I can't go down 3 and 4 to the right, so I can go up 3 and 4 to the left to get my next point. And I'm not going to be able to get a third point in on this case because of the way the line is setting up. So I'm going to use my straight edge and again make sure I'm making it very clear that this is a dashed line, which means any point on that line is not a solution. And again, I need to pick 2 points. 0, 0 is available, so I do pick that. Now, when I go to pick my other point, I do have a fraction there that I have to work with. So I want to use a number that works with the denominator of 4 to make the math easier. So I'm going to go to -4, -2. So I do need to, even though I can pick any points, I do want to pay attention to what that if my slope is in a fraction form, I want to pay attention to that denominator. And again, it just makes the math easier for me. So I have the point 0, 0 and the point -4, -2. Again, each of these points is giving me an x and a y that I'm going to use to substitute back into that original inequality. So 0 is less than -3/4 times 0 minus 4. 0 is less than 0 minus 4. 0 is less than -4. Is that true? Is 0 less than -4? That is false. So I'm expecting to get a true statement here with my other point. So -2 is less than -3/4 times -4/1 minus 4. So -2 is less than 12/4 minus 4. I had a -3 times a -4 to give me a +12. So -2 is less than 3 minus 4. -2 is less than -1. Is that true? Is -2 less than -1? Yes. So again, when I go to shade, I want to shade the side that has that -2, -4. So I'm going to shade this side of the graph. All the numbers down here are going to be solutions to that inequality. All right, C, y is greater than or equal to 5/3 x minus 4. Again, we're already in slope-intercept form, so we don't have to change anything around here. So we start off by looking at our inequality symbol. We have a greater than or equal to symbol here. So is that going to give us a solid line or a dashed line? This is going to give us a solid line, which means anything on the line will be included as part of the solution. So since I'm already in slope-intercept form, what is my slope here? 5/3. And my y-intercept? -4. So I start at my y-intercept of -4. My slope says to go up 5 and 3 to the right. And I actually do have room to go up 5 one more time and 3 more to the right. And again, all that second point does is to make sure that I've counted correctly and that my points are in a line. So then I line them up with my straight edge, connect them. And again, this is a solid line. So this is going to look like this is an equality because again, everything on that line is part of the solution. But we don't want just the line. We want everything that is greater than or equal to that. So we have to pick some test points. Again, 0, 0 is always one of my test points if it's not part of the line. And again, the only reason I choose that one and it's just easy to do the math quickly. So I need a point on the other side of the line. Now I have a denominator of 3, so I want an x value of 3. So I'm going to go with 3, 0. Again, the points can't be on the line. So we have the point 0, 0, and we have the point 3, 0 that we're going to have to test. Again, each of these is giving me an x, y. So 0 is greater than or equal to 5/3 times 0 minus 4. 0 is greater than or equal to 0 minus 4. 0 is greater than or equal to negative 4. Is that a true statement? Is 0 greater than or equal to negative 4? Yes, that is true. So we are expecting a false statement over here where we say 0 is greater than or equal to 5/3 times 3/1 minus 4. So 0 is greater than or equal to 15/3 minus 4. 0 is greater than or equal to 5 minus 4. 0 is greater than or equal to 1. And we know that that is false. 0 is not greater than or equal to 1. So we need to shade the side with the 0, 0. This is where all my true solutions would be. Anything on that line or on this side of that line would be considered a solution to the inequality. All right, problem D, y is less than negative 1/4 x plus 4. Again, we are still in slope-intercept form. So if I look at my inequality symbol, that less than, is that going to be a solid line or a dashed line? Dashed line. And what is going to be my slope here? Negative 1/4, and my y-intercept, 4. So again, I start there so that I can get my line graphed. Start at my y-intercept of plus 4. My slope of negative 1/4 tells me to go down 1 and 4 to the right. And again, since I can't repeat that again there, I can go back to my y-intercept and go up 1 and 4 to the left. And again, I need to make sure that I'm making it very clear that this is a dashed line. So making sure that I do have that space between, that it's very clear. And then once I have that, then I need to pick 2 points to test. Again, if 0 is not involved, I use 0, 0. And then here I have a denominator of 4. So I want to make sure that point I pick has an x value of 4. So I'm going to go up here and I'm going to choose the ordered pair for 5. So those are the 2 points I'm going to test, 0, 0, and 4, 5. So when I, again, making sure I remember these are giving me an x and a y. So 0 is less than negative 1/4 times 0 plus 4. 0 is less than 0 plus 4. So 0 is less than 4. Is that a true statement? Yes, 0 is less than 4. So again, I'm expecting to get a false statement when I do my math on this next one. If I get that this one is also true, I would need to go back and double check my math. So 5 is less than negative 1/4 times 4/1 plus 4. 5 is less than negative 4/4 plus 4. 5 is less than negative 1 plus 4. 5 is less than 3. And we know that is a false statement. 5 is not less than 3. So I need to shade the side that has that 0, 0. And again, making sure I'm shading the entire part of the graph. Again, it doesn't have to be solidly covered in, but I have to show that I understand that all of those points down there can be solutions to that inequality. All right, as we move on to the next page, now we started where we had just an X in one of them. Now we have just a Y. When we had just an X, it was a vertical line. So when we have just a Y, this is going to be a horizontal line at negative 4. And then if I look at my inequality symbol, is this going to be a solid line or a dashed line? Solid, it's that less than or equal to, that line under the inequality symbol. That's what tells me when I have to have that solid, because it's saying or equal to, so it needs to be included. So I go to negative 4 on my y-axis, and I'm going to draw a solid horizontal line there. And again, I still need to pick some test points. 0, 0 is available as one of them. And then on the other side of the line, I'm going to use 0, negative 6. And again, I'm only interested in the y coordinate here because that's the only thing that's in my inequality. So I'm only want to test if that's true. So the first one, 0 is less than or equal to -4. Is 0 less than or equal to -4? No, -4 would be to the left of 0, so -4 would be less than 0. This is saying 0 is less than -4. This is false. If I put in -6, is -6 less than or equal to -4? Yes, -6 is further left on the number line, so it's the lesser number. So this is a true statement. So I need to shade the side with the 0, -6. All right, problem F. Y is greater than or equal to x plus 5. Again, I look at my inequality symbol. Is that going to be a solid line or a dashed line? Solid, because we've got that line under it. So it is a solid line. What is my slope? 1. If there's not, remember, if there's nothing showing in front of that x, that's telling us that's 1. So my slope is 1 and my y-intercept is 5. So I start up at 5. Slope of 1 tells me to go up 1, 1 to the right. Since I can't do that again, I can go back to my y-intercept and go down 1 and 1 to the left. And again, it just gives me another point to line up and make sure that I'm going the right way. And this is going to be a solid line. And again, I need to pick a point on each side of the line. So I'm going to pick 0, 0 for this side. And then on the other side, because my slope is a whole number, I really can pick any ordered pair. I'm just going to go out here. I'm going to go to -5, 3. So again, I'm testing 0, 0, and I'm testing -5, 3. And I expect one of those to give me a true statement, one of those to give me a false statement, and I want to shade the side that gives me that true statement. So again, each ordered pair is giving me an x and a y. So 0 is greater than or equal to 0 plus 5. 0 is greater than or equal to 5. Is that true or false? Zero is greater than or equal to 5. That would be false. And then if I substitute in my second ordered pair, 3 is greater than or equal to -5 plus 5. So 3 is greater than or equal to 0. Is that true or false? That is true. 3 is greater than or equal. So I want to shade the side of the line that contains -5, 3, which would be this side of my line. All right, so up till now, all of our equations or inequalities have been in slope-intercept form. Now we get to problem G here. 4x minus 3y is greater than negative 12, and that is not the case. So if the equation is not in slope-intercept form, or if the inequality, not the equation, if the inequality is not in slope-intercept form, we need to solve it to get there. So if we're doing this and the y is not on one side of the inequality by itself, then we are not ready to start determining our slope and our y-intercept. So we have to make sure that we solve it to put it into that format. So if we're given 4x minus 3y is greater than negative 12, I'm going to start by subtracting 4x from both sides. So I have negative 3y is greater than negative 4x minus 12. Then to get y by itself, I have to divide everything by negative 3. And what happens in inequality when I divide by a negative? Because now we have to remember this rule as well. When I divide by a negative, what do I have to do? I have to reverse the direction of the inequality. So we're going to add another little note here. When you divide by a negative, you must reverse the direction of the inequality symbol. So when I'm dividing by that negative 3, now I have y is less than negative 4 divided by negative 3 would be positive 4/3 x. Negative 12 divided by negative 3 would be plus 4. So now I have it in that slope-intercept form. And again, I have remembered my inequality started out greater than, but I divided by a negative, so now it's a less than, which means I have a dashed line, a slope of 4/3, and a y-intercept of 4. So I start at positive 4 on my y-axis. Since I can't go up 4 and 3 to the right, I go down 4 and 3 to the left. And I use my straight edge to help me get that dashed line. Now we still have to test a point, but we're going to run out of time, so I'm going to pause there before we test and shade.